Um, like, in what way it's going?
Yeah, which way it's going? Is it going down or is it going up?
It's going up.
So it's positive, right?
Yes.
All right. And our very last one, let's go with Nathan.
No correlation.
No correlation, right. There's no rhyme or reason. I couldn't predict anything later on, so this is no correlation. Okay. Do you see with the negative and the positive, I could kind of draw a line that goes through those and I'd be able to predict what happens later on in the future. So that's part of our goal in this lesson is we're going to figure out what equation of the line goes through correlations that are similar to that. We can't really draw lines when there's no correlation. Okay, so we got negative, positive, no correlation. We also have strong and weak. Strong and weak means how well it's going to fit to a line. So I'm going to give you one that's pretty strong. And then one that's a little bit weaker. Okay. If you see this, is that almost all of those points can fit on one line here. This one's not quite as accurate if you just drew one line. So this would be strong. This is more of a weak correlation. Do y'all remember what like a random point out here would be called? Do you remember what those are called? If you have most of them are grouped all together and then you've got a random one. These are called outliers. So if they're outside of your like normal set of numbers, they're outliers. Occasionally, if you're doing statistics or data, some people will throw those out for the problem. Okay, so we got negative, positive, no correlation. It's strong, it's a little bit weaker. So any questions on the different types of correlation? Okay. Now we're going to take a set of data. We're going to make a scatter plot out of it, tell what kind of correlation it is, and then I'm going to show you how to use your calculator to get the actual equation of a line that's the best fit for that piece of data. Or Desmos, we'll use both of those. So I'll show you both of them. So we are going to find the equation of our line of best fit. We'll have a table of values. Oops, I'm going to label it by something. What's something we want to measure? Let's measure your time and your distance. Is that fun to measure? How long it takes, how far you can go? That's good. We'll do time in hours and distance. We'll do this in miles. Okay. You always want to know your units because that's going to help you out with the other stuff. So let's say we had 1 hour for 2 miles, 3 hours for 3 miles, 5 hours, 4 miles, 7 hours, 5 miles, and 9 hours, 6 miles. So we're going to plot our scatter plot, sketch our line of best fit, and then we'll be able to figure out a best line for that. Do we need a T graph or is an L graph going to be okay for us? An L graph is fine.
What an L graph?
And what is L graph? When you just have the positives. These are only positive numbers, so we only need the positive things. If you have any negative numbers, you need to make sure that you've got that. And we need to make sure that we're labeling our x-axis and y-axis. When you have a table, the x always comes first, the y comes second. So we have time in hours, and we have distance in miles. Do we need to do anything fancy with our increments, like go by tens or go by fives, or do you think going by ones would be okay? Let's go by ones. Okay, that's fine. You could go by twos if you wanted to, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Now we're going to plot these 5 points. 1, 2, 3, 3, 5, 4, 7, 5, 9, 6. You could go ahead and do a rough sketch of a line of best fit through here if you'd like to. So you can kind of see these are all in a straight line, so that's kind of nice. There's nothing random about them. If you want to find your equations by hand, you're welcome to try to do that by hand. To do that, I'll just tell you real quick. If you draw your line of best fit, pick 2 of the points that your line touched, and then you can just find the slope in between them and do point slope form. You remember if we've got 2 points, you can find the equation of a line between them. You can do that with your line of best fit with these. You can just find your 2 points and get your equation that way. But we can also let the calculator do it for us, especially if we have a lot of points. We might not want to worry about them, or if they're kind of large or something. But I'm going to go ahead and rough sketch my line of best fit through here. It's going to go like this. Is this a positive correlation or negative correlation? It's positive. Is it strong or weak? It's really strong. You see how tightly these points fit on this line. That's good. All right. Raise your hand if you have a TI-84 calculator, or you can pull one up on your school Chromebook. Okay, so I'm going to show you the method that we'll use to write the equation of this line if you have a school calculator. I don't have a way to pull one up on my screen to show you, so we're going to have to really listen. And you might want to write the instructions down too. So in your calculator, you're going to hit Stat. And then we're going to go over to Edit. And once you hit Stat Edit, you're going to get some lists like this. Your X's are going to go in L1. And your Y's are going to go in L2. So right now, if you have a calculator available to you, or you've got one on your Chromebook, go ahead and type your X's in L1, just in that same order, and your Y's in L2. So we're just going to, in the L1 column, 1, 3, 5, 7, 9. In the L2 column, 2, 3, 4, 5, 6. So if you pulled up your the one on your Chromebook, I bet you could. I don't know if you can type the numbers or you have to click them. So do we have our sets of numbers in our table? Okay. So in order for us to give us the equation of the line, once we have these numbers in it, we're next going to hit the stat button. So hit the stat button again. Arrow over to calc, and I have this written down for you too, and then hit the number 4. Then you'll go down and hit calculate. That's the last thing. So you scroll down to that. So we hit stat, arrowed over to calc, hit 4 for linear regression, and then hit calculate. All right, so somebody that did that, this is what you get on the screen. Y equals AX plus B, which normally we say M, but they say A. Does someone want to tell me what you got for your A value? Let's see, did anybody hit the stat calc 4? Can't see the chat right now. Oh, if you have an app on your phone, you can use it today for that. All right, so anybody gets an A value? The A value was 0.5. And what is the B value? Evelyn, did you get it, your B value?
No, I'm still doing the...
Oh, the other part, typing it in. Okay. All right, well, your B value is going to be 1.5. So they give you the A and they give you the B. So when we write our equation, we write Y equals 0.5x plus 1.5. All right. And part of your assignment today is to be able to interpret what these numbers mean in the context of your problem. So we're going to go back up to our original problem, but the equation of this line is 0.5x plus 1.5. All right. What is 1.5? Is that the slope or the y-intercept?
Y-intercept.
That is your y-intercept. So our b value, this is going to be our y-intercept. Okay. So if somebody asks you to describe the y-intercept in words, it's right here, 1.5. What does this ordered pair mean? What would this point mean? It's got an x value of 0 and a y value of 1.5.
How many distance how far they went in 0 hours?
Yeah. So if they're asking you what the y-intercepts mean, or y-intercept means, you will say that at 0 hours, the distance was 1.5. So if they're asking you to interpret your y-intercept, look back at your graph, think about what that would mean. 0 hours, distance 1.5. So you have a distance of 1.5 miles at 0 hours. 0 hours is another way to say your starting distance. So you started at 1.5, right? You haven't done any hours yet. You haven't had any minutes. So we have a starting distance of 1.5. That's what our y-intercept means in the context of this problem. All right. Now let's think about our slope. Our slope is 0.5, but we can also look at it that we went up 1 and over 2, right? So for every mile we went up, our time increased by how many hours? So we went up a mile over 2 hours, right? So you can say, this is the same as 1/2. 1, because miles were our y value, mile per 2 hours. So it's an increase of 1 mile per 2 hours. If it's 1 mile for every 2 hours, how much is it for 1 hour? How many miles would you increase for 1 hour?
Half a mile.
Yeah. So you could also say it's a half, an increase of a half mile per 1 hour. How do I know I'm increasing? And not decreasing?
Because the slope is positive.
Yeah, if the slope is negative, you're going to be decreasing. So that's going to show up in your answer. Okay. So you will have to interpret, once you get these equations, what the y-intercept meant and what the slope meant. So just think about what it means. Y value goes on top, x value goes on bottom for slope. Up and over or down and over. All right. Raise your hand if you do not have a school Chromebook and you don't have a TI-84 calculator and we're going to use Desmos for this, because you do not have access to either of those. Okay, so go ahead, and if you can make this screen a little bit smaller and also open Desmos up as well. So I'm going to switch over to Desmos real quick on here to show you that, just so you can watch it. So you're just going to go to desmos.com and hit graphing calculator. And I'll come back and write these steps down in a minute, but I want to show you this part. Okay, so what we're going to do is we want to add a table because we need to put our data in here. So you're going to hit this plus button and we're adding a table. We're going to type in the ordered pairs that we had. So our first one was 1, 2. So the X goes first and the Y. And then you can just do right underneath it, 3, 3. 5, 4. 7, 5. 9, 6. And what's nice is they went ahead and they plotted it for me, so that's good to see. So I've got my table in there, but I want to actually know what the equation is. So this is what you're going to type for it to tell you what the equation is. We're going to go down in row 2. So I'll click on row 2, and I'll write this out on the screen too.
How do you make the table?
You hit the plus button, and there's an option for table. And then this was Y1. So what I'm going to type is Y1. I actually just put Y1, just the number. All right. And then this is a 2-stepper to get this one little part here. I've got to hit my keypad, the ABC button, and a squiggle down here at the bottom. And I'll write that down too. But just to show you again what I just did, keypad, ABC button, squiggle. Okay. So I'm telling it I want to do a linear function. Remember, our equation is mx plus b, but I need to let it know I'm using x1 for my x's. So mx1 plus b. So y1, then I had to hit the keypad, ABC squiggle, mx1 plus b. And they drew the line for me, and they told me that m is 0.5 down here, and B is 1.5. Were those the same two numbers that we got when we did it in the calculator? 0.5 and 1.5? Yep, they're right here under parameters. Do you want me to show you that one more time? Anybody need to see it again, what I did? One more time? Okay. So I started a table. I hit plus and then table and typed in my numbers. Then for these subscripts, I don't have to make a subscript. I just put Y1. So I typed in Y1, keypad, ABC, squiggle. And then I went back and typed in M, X1 plus B. And that would give me my M and my B that go in for the equation. So I'll write that down in your thing so you can see it. So this is for Desmos, if you're going to use that. I don't care which one you use on a test. So the first thing that we did was we had to go to desmos.com and click Graphing Calculator. Okay, so that was our first step. And then we're going to hit the plus button and add a table. And you put your values in. And then on the next line, or on a new line, you are going to type Y1 squiggle M X1 plus B. And to get your squiggle, you have to hit the keypad, A, B, C, and then the squiggle comes up. Which just means congruent to, or no, approximately, not congruent, approximately. And Y1 is really literally Y1, and X1 is just X with the number 1. You don't have to do anything fancy. Okay. Occasionally, you're going to be asked to make some predictions. Okay. So they will say, make a model, and these equations that we make are the models. And then they want us to predict for certain values. So we're going to use the model that we just had, which was y equals 0.5x plus 1.5. And we're going to do 2 prediction problems. We're going to first predict the distance after 100 hours. And then we're going to figure out how long will it take to go 200 miles. So after you have your model, and sometimes they just give you the model and they ask you the questions, they want you to use the equation you have to figure out the answers to these questions. So we have to realize what is the x and what is the y, because that'll help us know what we need to plug in. Okay. What was x? What was the x? The x was our, I'm just going to look up, I'll put it back down. So x is time, y is distance. That's going to be important for us, so you might want to write that down when you're doing your problems. This is time, and this is distance. Spelled distance wrong, distance. If you have an equation and someone said predict the distance after 100 hours, is 100 hours a time or a distance?
What was the question?
Is 100 hours, is that a time or is that a distance measurement? That is, I see T for time. Yep. That's a time measurement. So if they want you to find the distance, we don't know the distance yet, do we? We know the time. So when we are plugging our 100 in, are we going to plug the 100 in for X or are we going to plug it in for Y? Yeah, you're going to plug it in for X because X is time. So when you have these prediction problems, you need to figure out, is the number they give me, is that going to go in for X or is that going to go in for Y? So I always make sure I know which one is time and distance or whatever measurements you're using. So I'm just going to plug 100 in for X, and that will give me my distance after 100 hours. So Y equals 0.5 times 100 plus 1.5. We can put that in the calculator super fast. So 0.5 times 100 plus 1.5 is going to equal 51.5. And then what is our distance measurement in? Miles, yep. So 51.5 miles after 100 hours. This must be like a snail or something. All right, part B says, how long will it take to go 200 miles? Is 200 miles a time or a distance measurement? It is distance. So this is distance. And is distance the X or the Y? Yeah, it's the Y value. So our 200 needs to get plugged in for the Y value because that's what we know. So this is a Y value. So that's the only place we could put 200. So we'll put 200 equals 0.5x plus 1.5. Do we see the difference in these two problems? The first one had to go in for X because it was time, and X is time. But the second one was distance, so it had to go in for the Y value. Okay, and now we want to get X by itself. So what's our first step? Let me see. I'll call on somebody real quick to let me know what that first step is. How about Carrington, your first step on this problem? We're trying to get X by itself.
You said X?
Yeah.
When you divide it? Well, try to single it out. I don't know. So yes.
You want to get X by itself? Are we going to move
Yes.
the 0.5 or the 1.5 first?
Yeah, move the 1.5.
Yeah, the 1.5. So we'll subtract the 1.5 on both sides. So 200 minus 1.5, 198.5 equals 0.5x. Okay, and then we have one last step. Then we divide by 0.5.
Yeah.
And that 0.5s go away, and x equals 397. Okay. All right, so what I'm going to do right now is I'm going to give you guys a set of points. You can either make your equation using the calculator or using Desmos. And I'm going to give you a set of points. I just want you to have your equation. And then I'm going to give you 2 predicting problems for you to figure out real quick. Okay, So everybody needs to do this. So if you are not visible, go ahead, get visible, get those cameras on. I'll be checking you off in my notebook to make sure that you have done this particular problem. So here we go. Let's go with years, population. Okay, so these are our years, and this is a population in thousands of a particular town. So I want you, the first thing I want you to do is make your model. And your model is your equation, y equals, so you can use your calculator to do it, or Desmos.